pause if you want time to say something that you don't want recorded. But what I hope is that you'll ask questions and then that'll be recorded, and whoever's watching it, whether it be you or whoever's recapping, can learn from your question as well. So, like I said, the question, we have to pick out the information. So we've got the fact that we're talking area. As I said, ignore the answer. You've got to get to the answer and then look at it and check you're right. It's like being given the mark scheme for a test. You can't look at the mark scheme and just write the answer. You work out the answer and then check your answer. And that's what this is intended for. So, what we've got to do is to show that the area of the quadrilateral, so we're looking for the area of this quadrilateral here, right? Again, feel free to write all over diagrams when you're doing it in an exam. That's the quadrilateral we're looking for, because it says PQRS, so P to Q to R to S. So first step is working out which one. How do you work out the area of a quadrilateral?
Length times width.
Length times width. And you know what, first time I looked at this question, that's what I was thinking as well.
Times height over something divided by 2.
That's what triangle.
Well, yeah, triangle or trapezium, which we're looking at. This is, the reason why I know this is actually just a rectangle is because this distance is x, that's x, that's x, that's x. It's the same from each corner, which means this, although it doesn't actually look like it, it is a rectangle. So actually, we just need to do this times this. Now that's one way of looking at it, but actually when you try and do that, the maths is pretty hard and doesn't come out to look like this. So there's actually an easier way, and I would say we've got to go for the easier way. With everybody notice there is only 3 marks. Okay? So the other way, anyone thought of? Can think of a different way? Well, you okay? Yeah, Pythagoras, you've worked that out. That would be one way, Pythagoras' theorem, but that is actually a harder way. So what we have,
Isn't that longer as well?
yeah, it would be quite a long one. Yeah, really, quite a tricky one. But what we've got here is we've got a bigger rectangle and we've got a smaller one in it. So what if I work out the area of the large rectangle and then subtract the areas of triangles? Does that make sense? Oh, is that what you're interested in?
Yeah.
Okay. Well, then we don't actually need Pythagoras. So we're going to do large rectangle, subtract the triangles. Okay. So we've got one triangle there, and this one's actually the same triangle, so I'm going to call it 1 and 1, and this is 2 and 2, because you've got 2 triangles the same, 2 triangles the same. Okay, so we're looking at the large rectangle, subtract the triangles, and then that will give us the area in the middle. So what is the area of the large rectangle? So we have to take that information. So we've actually got the whole thing is 10.
10 by 8.
10 by 8. So 10 times 8. So we've got 80 for that. But then we've got to subtract the triangles. Now, just going to write down here where I put some space, and you've got the whole thing. So if you remember that on your screen you've got 2 of the same triangle on either corner, right? So what I'm going to do is I'm going to draw a little sketch. This is how I would always do my exam questions to make sure I know exactly what I'm doing. These are the 2 triangles, and I've got 2 lots of that one, and I've got 2 lots of that one. Okay? So what are the dimensions of my triangle? Well, the little ones are x and what? That's the question. Now this is where the maths really kicks in. So I'm going to, it's x and what? So this is where you are forming equations. Any ideas? So you are basically looking at this length. Yeah, spot on. Because you've got this one here, that's x, and this whole one is 8. So this bit must be 8 minus whatever that x is. So I'm going to write that on this triangle. So it's 8 minus x. Is anyone unsure about where that comes from? No, everyone's okay with that? So that would be 8 minus x. Because 8 minus x plus x makes the 8. What about the other one then? If that's x, this is 10, this one must be? So that's it. So 10 minus x. Be careful you get that the right way around, not x minus 10. Because it does affect it. So this triangle here is the second one, the slightly longer one. So again, it's x and 10 minus x. So what's the area of a triangle then? Base times height divided by 2. So if I write it's a half times, a half times, do you understand that multiplying by a half is the same as dividing by 2? Okay, so a half times x times 8 minus x. Now here's where it's worth writing things out, because how many of them do I have? 2. So it's actually 2 times a half. And what does that do for me? Cancels. 2 and a half cancel out. So we then get left with x times 8 minus x. And then what about this other one then? So it's again 2 times a half times x times 10 minus x, which again is just x times 10 minus x. Okay? Yeah?
Where did we get the half from? Yeah, it's kind of confusing.
Okay,
Yeah, can we just
so
write
a
that?
triangle, area of a triangle is base times height divided by 2. So instead of divided by 2, I use the half times base times height.
So we could do it divided by 2.
You could do it divided by 2. The only reason I did it a half times is because then it's really clear that 2 times a half just cancels itself out. Right, what do you think you do with those values then? So we've got this one and this one. What do we have to do with them? Subtract it. Do you have to do anything with those first? Because remember, it's the large rectangle subtracts all of the triangles. So we could add them together first, yeah? So I'm going to do x, 8 minus x, add x times 10 minus, because this is the sum of the triangles. We have to, how do you add those together? Expand and simplify. Go on then, I'll let you do that while I pause. Okay, so expanded, simplified, collecting like terms. So we've got plus 10x, 8x makes the 18x. We've got minus x squared, another minus x squared, is minus 2x squared. So all of that needs to go back up here. So it's subtract. Now we've got to be careful with subtract, that we do write in brackets, because we've got 18 minus 2x squared. So this would be the place where people potentially might make an error. So that means the area would be the result of this. So what would that be? 80 minus 18. But what about the minus 2x squared?
Wasn't it 18x?
Sorry, it is 18x, yeah. I keep forgetting to write it. So that would be, sorry, plus 2x squared.
Oh, that's
And yeah, then we go, right, that's what I've got. Well, what do they want? There might be something extra, but actually, Is that and that equivalent?
Yeah.
It is, yeah. So we just check plus 2x squared, yeah, minus 18x. Do I need to rewrite it? No, it's done. It's all done. Okay.
Can you go back down, please?
Just to show that we got the same thing.
First ourselves. Right, we're back in the room. So we've got a trapezium. We've got another show that. We're not allowed to use that. We have to find it, so ignore it's there at the moment. But we look at this and we read and decide what we're being given. Now, I noticed that the first piece of information I'm given, really, because all of that is on the diagram, it says the area of the trapezium is 42. So that means that this formula is going to come from what? Working out the area, right? That's the clue, the area. So I'm going to basically find the area. And I know the area is 42. So we just have to remember the area of a trapezium. And the area of a trapezium, you may or may not remember at the moment, is A plus B times H, all divided by 2. And on the diagram, the short side is the A. Well, it doesn't matter actually. One of the sides is A, one of the sides is B, and the perpendicular height is the height. Okay? So, if I do that, the area is equals, I can forget about area is equals, and put equals what?
42.
42, because that's the piece of information that we've been given. So once I've ploughed these in to A, B and H, simplified, worked it out, I should end up with this. And that's it really. Just about how good are you at doing your rearranging and simplifying and things like that. So shall I leave you to it for a bit? Okay, so we've got A and B. These brackets are there because they're up there, but actually, because it's all adds, we don't need those brackets. Okay, and then we've got times by the height, and then we've got all divided by 2, and that equals. So all we've got to do, what's inside the bracket?
2x plus
Over 2, all that times by x equals 42. Right, if you've got that far, I'll let you carry on. Okay, let's have a look then. So I'm pretty sure most of you are there. So we have to expand the bracket, so we get 2x squared plus 13x over 2 equals 42. This whole thing is divided by 2, so actually we should multiply both sides by 2, and that gives me 2x squared plus 13x, no longer divided by 2. The other side is 84. Up here I noticed I want equals 0, so to get that I need to subtract 84, which means I do it this side 2, giving me 2x squared plus 13x minus 84 equals 0.
Makes sense.
I've got 1 actually, and that's all I need, unless I actually put those to TV. Okay, next part then is that we've got to calculate the perimeter of the trapezium. Now if we look at the trapezium, what would you need to know to work out the perimeter?
All the lights.
And what is that? How do I find out all the lengths? What do I need to know? X. So basically this part here, find the perimeter, is find x. And we've got this equation, so we've got to solve 2x squared plus 13x minus 84 is 0. Now, what would you do? You could use the formula. This one does actually factorize. It does factorize. But if you can't see it straight away, yeah, just use the formula. Anyone see it, how it factorizes? So it's going to be, definitely got to be 2x and x. So what do you think?
16x.
16 times 4? 16 times 4, does that give 84?
No. It doesn't.
16 times 4, 4 times 10 is 40, plus 24 is 64. Not quite.
Times 6.
Oh,
But do you remember how you've got to do it?
16 times 9.
So we've actually got to do two, we've got to split the middle term, haven't we? We could do it, split the middle term.
It's like 2 times 84, right?
Yeah, so if we do 2 times 84 is,
168.
okay, and then we need two things that multiply to make 168 and add to make 13, but it's got to be a plus and a minus, hasn't it?
Yeah.
So it's not an easy one by any means. Definitely not an easy factorise. Anyone think of it? I think I did work it out on my bit of paper. It's like I said, it's not the simplest one. The bracket, anyone? Figure it out?
So if you want to give me 84, which number is 13?
Anyone there?
No.
So basically the brackets will be 2x plus 21 and minus 4. Okay.
Do you think it'll be hard ones like this in the test?
Well, these come from IGCSE and they're harder. It's the harder end of the paper, definitely. But like this one, you don't necessarily have to factorise. Once you factorise, the answers are really easy. But actually, maybe you prefer to use the formula. Yeah.
And the test features, like, do you have part A, part B, and part C still?
Well, the test will be coming up. So when we factorise, we get our two solutions. Now you've done this before. So how do I find the two solutions? So this one's easy. For the second bracket, x must be. Remember? Now it's in the null factor form. A times b equals 0. So that means either.
X equals 4.
So either 2x plus 21 is 0, or x minus 4 equals 0. And in this case, x has to equal 4. And in this case,
X has to
so
equal
2x equals negative 21, x is negative. Right, so we've got two solutions, but because we're in an actual applied situation, which answer do we have to use? And why? Yeah, y v equals 4. Because it's a... It's not actually because it's a whole number, that doesn't matter. The problem with this one is not the fact it's a fraction. It's negative. Makes no sense. A negative length makes no sense. So we've got x equals 4. So the trapezium then, if we go back up, we've got x plus 5 makes that side 9. X is 4. And x plus 8 is 12. Now, have we got enough information?
Yes, kind of.
Kind of.
Yes, we do, because you could do Pythagoras' theorem.
Yes. Okay. So we've got to work out this length. So if I break this up into a triangle, what's the dimensions of the triangle? So this height is 4. This one is 3.
I
Here.
know it's 3, because you need 12 take away 9.
12 take away the 9 there, yeah. Right. What would you use to work out the side?
Pythagoras.
Pythagoras' theorem, definitely.
A squared plus b squared equals
A squared plus b. Does anyone spot how you do it quickly though?
What did you...
Not socket side, but well, no, we can't. We haven't got an angle. But it's Pythagoras' theorem, so we could do c squared is 3 squared plus 4 squared.
3 squared is not...
But does anyone remember the special triangle? I know I haven't got one of you, but I'm sure you did it. 3, 4, 5.
Yeah, I remember that.
Remember that? That's one of the
You remember that?
Pythagorean triples.
That's what Miss Harrison kept talking about. 3, 4, 5. She said exactly.
3, 4, 5 triangle. Yeah.
Wait, so if it's 7, 8, so it'll be 9.
No.
No. It only works with 3, 4, 5.
No, it would work with 6, 8, 10. But this is like the first one that's really easy to remember, and they use it quite often. So you can still work it out. C squared would be 9 plus 16. So C squared is 25, which means C is square root of 25 is 5. Still work it out.
16
But
plus
it
9
saves you a few
is
seconds.
25.
Yeah.
Oh.
So then we've got 9, 4, 12, 5. There's your perimeter. Okay.
Yay.
9, 4, 12, 5.
Wait, can you scroll back down really quickly? I just forgot to copy something.
I did not get that one.
Okay, so what we've got here, we've got a rectangle, right? And we're looking for the information, and it says the perimeter is 72. So there's a piece of information that we're given. So we're going to have to use that. Okay. We are asked to find what area equals there. Right, show that area is. So what we need to do is start writing things. Now what's different about this one is that we've got x's and y's, where the other one, right, the other two, it was all x's, wasn't it? X plus 5, x plus 8. Up here it was x. You have to work out 10 minus x. So this one messes things up by having a y.
Where is the background, please? Thank you.
Okay, so what we have to do though, even if we've got y, let's write down what we know. So for instance, we've got to find area. So actually the first thing to do is let's write something for area. What would it be?
X
Times y.
XY.
xy. Alright. That isn't what we want. We don't want any y's. We've got to get rid of y's. But let's write something else. So the next piece of information was perimeter. So can you come up with an expression for perimeter?
2x plus y equals 3y.
2x plus 2y, and what would you put it equal to? P? You sure?
72.
Yeah, good. 72.
Who said P?
A couple of people. It makes sense, but if you haven't noticed the 72, it would make sense. Okay, so this is where I've got simultaneous equations, and it's simultaneous equations because I've got two different equations on the same situation, but they are different. They're not just one that's been rearranged. One's for area, one's for perimeter. So we do have simultaneous equations. And we need it when we've got two unknowns, x and y, we need simultaneous equations. Okay. So we're going to use a substitution method. And that means what we have to do is replace either the x or the y with this one in a different form. Now, what do I want to... Yeah, go on.
Can you repeat? I don't know, just saying.
Yeah,
Right, well, it'll make more sense when I actually start to do it. So, the information I've got, right, I've got to have the x's, right? I've got to keep the x's. That means I've got to get rid of the y, all right? I need area equals, so this is the one I'm using. This one I've got to use to replace the y with x's. So what I do is I rearrange the one that I'm using, I rearrange it so that I've got something for y. So this one has to be rearranged so that it's y equals. Okay? Has to be y equals. Right. So it has to be y. So let's rearrange 2x plus 2y equals 72. to be y equals, what would you do first? Okay, how do you do that?
Divide.
See, my way is to do, whatever I've got to x, I'll subtract 2x. Yeah? So you've got 2y equals 72 minus 2x. Yeah, you hand up.
Oh, I was just gonna do the next one.
Yeah, next bit.
And then you just move the 2 over, so then it'll be 72 minus 2x over 2, right?
Okay, I'm going to call that divided by 2. If we've got times 2, I'm going to divide by 2. If you want to move it, you're fine. 72 minus 2x over 2. Is there anything I can do about that to make it a little bit simpler?
You can
Yeah.
divide everything by 2.
You can. So that would become 36. Well, that's nice. Minus x. So we're not quite there, but we're definitely getting closer. Right.
Wow.
Now here's the substitution thing. So basically, we have question.
36 come from?
Because
72 divided by 2. 72 divided by 2. So we've got y equals this. And in the other equation, I will come back, don't panic, we've got an x times y. So let me just... So we've got our other equation, a equals xy. So what I'm going to do is replace this y with 36 minus x. That's the substitution. So we then have a equals x times 36 minus x. Do you remember doing that now, the substitution method?
Nope.
Yeah. So,
I remember we were given the numbers to put into like X's and Y places.
Well, based on what you're supposed to have done, I think you will have done that. Whether you remember it's a different matter, but obviously this will recap. What do I do now? Expand, and we get 36x minus x, which is what I want. It's there, it's done.
That's it.
That's it.
Remember to do the first one.
Yeah. And there's nothing else to that question, that's it. So again, do you agree with me that the maths itself is not that hard, but it's the forming it?
yeah, and like the data.
It's picking out the stuff that you need to use, and that's the hardest bit. And if you just look at it as a block of text and I don't know, you're not going to be able to do it. Right, let's have a look at this first one. Now, although, yeah, this probably is the hardest one. Who knows anything about percentages and profit and all that kind of thing?
It's like
Profit and loss.
Profit and loss.
it's like percentage times money.
So can I just check, do you know what profit, how do you work out profit?
Revenue minus the total cost.
Okay, so if we look at here,
I think it counts.
Claire buys and sells. So profit would be
Sell.
the selling minus the buying price, yeah?
That's on the wrong sheet. Don't worry,
Oh my
I can
god.
answer it.
Oh yeah, they get to go home, don't they?
recorded in the law.
Oh, they got to go home and view it. Oh.
That's all right. Our mess up is not on film. Profit divided by what she spent. Okay. So the bigger one.
So
So-
expenditure.
So what she bought it, expenditure. Yeah. I'm using my non-economics, economist, yeah. 5 different ways.
You guys are killing
Is that divided by that multiplied by 100? Okay, so that would be the percentage. Right, so her profit divided by what she spent. So maybe we could use different words, you know. So that is for you economists, expenditure and income, yeah?
Oh no, that's just confusing.
Yeah. Alright, so that's the hard bit, because if you're not into your economics, you won't necessarily be able to do that. But we've got to set it up so she makes a profit of X percentage. Right? So the profit, scale minus value. So we've got 600 plus 5x subtract 50x, okay, divided by 50x times 100 equals, makes a profit of X percent, X. So this probably,
Not going to be on the test, right?
no.
Excuse me.
I wouldn't give you this
50
one.
after 50x just cancel.
Oh, well, that's a good question. Will those two 50x's cancel out?
Yeah.
No.
No.
It's a minus and a divided.
Good, yeah, spot on. It would if there was a 50x in all three parts, but there is only that 50x, that minus 50x is only cancelled by an add 50x. Alright? But it's a divide, so it doesn't cancel. But what do you think we need to do at this stage?
Add like.
Yeah, rearrange and simplify. So what do you want to do?
Move the 100.
X divided by
100.
100.
Let's move the 50.
Okay, so what I'm going to do is I'm going to do 600 plus 5x minus 50x. I'm going to leave it all as times 100, but we're going to make this over here 50x squared. Okay? Got me? Are you all happy with what I've done there? Yeah? Everyone happy?
Yeah.
Could have been happier, but it's alright.
Could have been happier. Alright, I can deal with that. Right. I'm going to leave you now, at this stage, to get from that point to that point. Alright? Go for it. So you're going to go from where we are to where they want you to be. We've done the hard bit. We need to get from this. So expand the bracket to the multiply by 100 and then do something with the 50x squared and get it to this. Okay, so what I've got, by doing the minus 50x squared, I've got it all on this side. That gives me the equals 0 I need.
Yes.
Right. But there are two problems, which is in the question it wants x squared plus 90x minus 1200. So what I've done, in your way of thinking, I'm moving, right? So actually, if I shift all this side, maybe I should, instead of doing that, I'll write it equals 0 there. Maybe that. Does that make more sense? Okay. So I've just shifted everything that way and changed the sign. I hate that, by the way. But if you're happy with shift, it's not the truth. I should add 50x squared, add 45 that, and add and subtract 60. That's why I end up with that. Okay. The next stage is I only want 1x squared. I've got 50. There's the clue. Divide everything by 50, and you have to do each bit. 0 divided by 50 is still 0.
Why is that?
Because you've got nothing, and you divide it by anything, you've still got nothing.
Oh, no, but why do we have to divide by 50?
Because we want 1x squared.
Okay.
So 50x squared divided by 50 is 1x squared, and it just so happens that 45,000 divided by 50 is 90, and 60,000 divided by 50 is 1200. And that's the answer.
That makes sense.
Yeah. That's great.
Okay. Now, what we're not going to do, because I think you know what it's going to be, is it says now just find the value of x, correct to 3 significant figures, which means you're going to do what? The quadratic form.
Oh, I have a question. On the assignment it said exact form. Is that the decimal?
No, exact form is thirds, completed square forms and things.
I need you.
You are.
Right, right.